Hi guys, welcome to this set of videos. What we've been doing here is sort of, as we go through chapter 5, we've been looking into this theme having to do with polynomials. And so far what we've seen from polynomials is that we can do several basic operations with them. We can add them, subtract them, multiply them. And then in the last section, section 2 of chapter 5, we looked at dividing polynomials. Using two different methods, the algebraic division and synthetic division. But now what we're going to do here in chapter 5 is kind of change gears a little bit and begin to think of polynomials as functions. And what is it going to look like if we begin to graph some of these polynomials? So that's exactly what you're going to see here in section 3 of chapter 5. We're going to begin to look at polynomials as functions, and along with that begin to delve into a little bit of what it means to graph a polynomial. So a couple of objectives or learning targets for you as we head into this set of notes. You're going to want to be able to evaluate a polynomial function. We've had experience evaluating functions already. That's kind of a big part of algebra, evaluating a function, but we'll go over that a little bit here to get started in this set of notes. And then we get to the graphing part. So you want to be able to identify general shapes and graphs of polynomial functions. Now, what's going to happen here as we begin to go further into chapter 5 and graphing polynomials, you're going to find sort of a lot of conceptual stuff. What that means is there isn't really any algebra that you sort of have to work through. It's actually going to more kind of be facts that you have to memorize, things that you have to know, so that when you look at the polynomial you've been given, you can quickly sort of determine a few things about its graph without actually having to do any algebra. Just by looking at the polynomial, there are some things that you can know. Now, for some kids, this works out great, right? The conceptual stuff, it's easy to memorize. You just look at the polynomial and right away they know, okay, I know my graph is going to have this and it's going to have that and that's other stuff. For some other kids, this is a little bit tricky to kind of get a hold of, especially in an algebra class where you're so used to having to arrive at your solution by working through some sort of algebraic process. Well, that's not really going to be the case here as we get to the end of this set of notes, where it's, like I said, going to be kind of conceptual. But let's go ahead and start off with this evaluating polynomial functions. And before we do that, what you're going to want to be able to do is make sure that you can get your polynomial into what we call standard form. Now, for the moment, just sort of ignore this. I just wanted to show you in general what a polynomial looks like. All of these a's out here are constants. They're coefficients, okay? They just have a different subscript so that I don't accidentally think or get confused and think that they're the same number, right? They're not the same number, right? an is not the same as an minus 1. It could be, but right, they don't have to be. And then of course my variable is x, so I have x to the n power, x to the n minus 1, all the way down to x squared, x to the first, and then x to the 0, where I don't have a variable, right? So this is just a polynomial written in general form where a can be any number, any coefficient, and then x is raised to its power. And remember, these are finite. They are not infinite, so n is going to be some real number. Okay, so the idea here is this. In order to write a polynomial in standard form, you've got a couple of things that you need to have happening. First of all, the polynomial needs to be written in descending order of power. We've already seen that. In fact, we practiced that a little bit in previous note sets, so no big deal there. A couple other things I want to point out to you, and we've already seen these. The degree of the polynomial is the same as the largest power of x. We know that the degree of the polynomial is equal to the largest degree term in that polynomial. We've already looked at that in previous note sets. And then one more thing, the leading coefficient, which I don't believe we've talked about yet. The leading coefficient is going to be the constant in front of the highest power of x. And again, why do we call it the leading coefficient? Well, if you've written your polynomial in descending order of power, that means your largest power of x comes first. And so the number in front of that is going to be the leading coefficient. It will be the number at the very beginning of your polynomial, and the rest of your polynomial kind of goes from there. So that's why we call it the leading coefficient. as long as you've written it in standard form in descending order, that very front number is going to be your leading coefficient. So let's go ahead and take a look at how these are going to go. What I will do is I will give you some expression. You'll need to figure out, is it a polynomial, which we've already talked about how you determine that, so we'll get a little more practice here. And then if it is a polynomial, I ask you to do a couple of things. I ask you to state the degree, the leading coefficient, and then of course determine if it is a polynomial in one variable, which just simply means, right, are all of your variables the same, right? You either have all x's, or you have all y's, or you have all z's, right? You don't have any variables mixed. So here we go. First of all, I take a look at it and I can easily see I don't have any square roots, I don't have division by any variables, and I don't have any negative powers. So yes, this is a polynomial. Doesn't break any of my rules that would say it isn't a polynomial. So now that I know it's a polynomial, I want to go ahead and get in standard form. 5, I don't have an x to the 4th, 3, 2, 1, 0, so it is already written in descending order for me, which tells me a couple of things. First thing it tells me is that the degree is going to be the largest power of x. In this case, it's a 5, so that would be a 5th degree polynomial. And because it's in descending order, that front term is going to be my leading coefficient. So 8 is my leading coefficient. So that's the way that these problems are going to work. I got a few more for you on the next page of the notes, so we'll head over and try some of those. But again, just determine, is it a polynomial? If it is, make sure it's in standard form. Find the leading coefficient and determine the degree. So let's try a few more of these. We'll run through these pretty quickly. I got another one for you here. Is this a polynomial, and is it a polynomial in a single variable? And so we take a look at it and we see that it is not. I actually have an x and a y, so not a polynomial in a single variable. Now, why does it matter that all the variables are the same? Well, remember, what we're going to be doing here in this set of notes is we're going to begin to take a look at graphing. And we know that in order to graph a function, all of the variables have to be the same, right? I can't have I can't have two different variables in the same function and have any success with graphing it unless you get into the parametric graphing and parametric coordinates and stuff like that, but we're not going to touch that here in this section. So we need all of our variables to be the same. So we go ahead and move on to the next one. I take a quick look at it. I notice that all of my variables are the same. I don't have any square roots or radicals. I don't have division by a variable, and none of my exponents are negative. So this one is a polynomial. It is not in descending order, so I'm going to need to rewrite it. Negative 4x to the 8th plus 3x to the 4th plus 6x cubed plus 2x. Now I have it in descending order, 8, 4, 3, 1. And once I've done that, I now know that it is an 8th degree. It's an 8th degree polynomial, and my leading coefficient is a -4. That's good work. Let's go ahead and try another one. Slide this on up. Okay, so here we go. Again, real quick here, let's check to make sure I am all in one variable. All I have are x's. I don't have any radicals, I don't have division by a variable, and I don't have any negative exponents. So yes, we have ourselves a polynomial. Okay, I then need to make sure that I'm in descending order, which I am not. So negative 6x to the 5th plus 4x cubed plus 2x squared plus 9. And now we can just rattle this stuff off. I am going to be 5th degree. And I am going to have -6 as my leading coefficient. The next one, I see that it's all the same variable, so I have x, 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 and x, which is awesome. I don't have any radicals, I don't have any negative exponents, but I do have division by a variable, which is not allowed in order for this to be a polynomial, so this is not a polynomial. It breaks that one rule where it says you can't have division by a variable. So we're done there. It's not even a polynomial. I think I got two more here. We'll run through these real quick. X, 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 all my variables are the same. No radicals, no negative exponents, and I don't have division by a variable. So this is a polynomial. My degree, I need to make sure I'm in descending order. It's already in descending order of power, so I know that I am 6th degree. And my leading coefficient is a 5. Okay, let's take a look at the last one. X, x, x. I've got all x's. I don't have any radicals. I don't have division by a variable. I don't have any negative exponents. So once again, yes. This is a polynomial. It is not in descending order. Negative 6, negative x to the 6th, 8x to the 4th, 2x to the 3rd. Once I've got it in standard form, I can quickly see that I am a 6th degree polynomial, and my leading coefficient is a -1. That's a -1 out front. And so guys, what that does, just real quick, hopefully that's a quick review for you on first, how do you determine if it's a polynomial? Check to make sure that it's a polynomial in one variable, and then again, just how do you find the degree of the polynomial? And then the leading coefficient is real easy once it's written in standard form. Head on over to the next page of the notes and we'll take a look at that first learning objective or target, which is going to be evaluating a polynomial. So I'll meet you over there.